Hey guys, so I decided to make this video because I've seen a lot of questions about it, mostly on the Scripting Helpers Discord, and it involves basically how do you animate things, or, how do you smoothly transition the properties of, some object. And immediately I would say my response to that is to use TweenService, because that's what it exists for. But there's a lot of times people, for some reason, don't want to use TweenService, or they don't know it exists, or they just want to do it themselves just for the sake of knowing how it works. Because what I'm about to show you is basically how TweenService works under the hood, or at least it should be pretty close. At the very least, it's the same kind of concept. So, yeah, what I'm going to do here first is I'm going to smoothly transition the transparency of this part, and I'm going to show you guys the right way and the wrong way to do it. So the wrong way is what most people do first, and this is just a quick and dirty for loop. Well, first let's have access to the part here. Yeah, the quick and dirty for loop, so it's like for I equals, let's see, how does this work in? It's, that's embarrassing. I kind of forgot how the step works. Alright, sorry, I don't know what happened with my brain there for a second. So yeah, they'll start off with just using a for loop, so for I equals 0 to 1 typically, and then they'll have some kind of increment like 0.01 or 0.1. Another thing I would note about doing this is that with for loops, the increment is a little bit, you never want your increment to be a decimal. And that's just because there's this weird thing with how the counting works in binary under the, like, behind the scenes, when your for loop is actually running. So I'll give you an example. If we have, it doesn't cause a problem with the tenths place, but when your increment gets into the hundredths place, I'm pretty sure that's where it starts getting kind of weird. So if I run this, real quick, we'll just print out our variable there. You'll see we get what we expect. It goes from 0 to 1 with a step of 0.1. But if we change this to 0.01, then I'm pretty sure this only stops at like 99, or it's like 0.99997 or something. Okay, so yeah, here it stops at just 0.99 instead of 1. So that's already kind of a problem. If we change this to maybe the thousandths place, it's just going to get worse the more zeros you add, or the smaller the increment is as a decimal. If we run this, yeah, so that's again 0.9. I'm wondering when it was exactly, I thought I got like some really weird numbers, but come on. Yeah, there we go. So, I mean, point is, don't use a decimal number for your increment. If you really need to use like something like this, just simply change this from, instead of 0 to 1, do 1 to 10, and then just divide I by 10. Like, it's that simple. Or, whatever your max value is here. If it's 100, just divide it by 100. So, just keep your numbers up here in your for loop whole numbers. And if you really need them to be a decimal, then just divide them later on in the body of your for loop. And if you run this, then you see we don't get that weird just stopping at 0.99 thing here. It goes all the way up to 1, which is our end value there. So, just another tip that I would use with numeric for loops, something that you should remember. Let's see, where was I? What was I doing? Oh yeah, So when you get to animating with using for loops, with that old problem aside, if I want to change this part's transparency from, let's say, 0 to, we'll just do 0 to 1, then I could do part.transparency is equal to I divided by 100. So it would start at 1, sorry, it would start at 100th and it would go to 1. So over some wait time here, which you would want to add normally, otherwise it would just do it instantly. So let's just put wait there. This will change the parts transparency from 100th to 1 over this time for each iteration. So if we run this, you should see that it kind of slowly fades invisible. And it looks kind of smooth. It looks smooth, but it's really, first of all, there's a much better way to do it, obviously. That's why I'm making this video. But once these values get to be smaller, or once your game is busier, and by busier I mean there's more resources that are being shared or hogged in your game, then this might not look as smooth. In fact, it most likely will not look as smooth. Not only that, you're going to have synchronization issues. So that's another issue with using just a for loop and a constant increment. You never want to use a constant increment when you're animating something, because like I said before, time in your game, or time just in computing in general, is not linear. So you want to make sure that you're animating based on the time that is being kept track of by the computer. So your increment should be based on where your computer is at time-wise. So the way that we can do that is by getting rid of that for loop. And the first thing we're going to do is we're going to get run service, because run service is responsible for, well, basically everything in your game that's being rendered or that's updating. So let's get run service. And we're going to use an event listener of run service called render stepped. And render stepped is basically an event that fires every single frame of your game, which I think the wiki says is about a 60th of a second. That was the old number. I'm not sure if it's different now. But it's roughly 1/60th of a second. Okay, I don't really know why I said that. Obviously, render stepped is not going to run at a constant rate. It's just going to run at whatever your actual game FPS is. So that's just going to depend on your computer. So sorry about that. So what we're going to use is a method called wait on that render stepped event. So this is a pretty quick way to wait for something. I wouldn't really recommend using this like everywhere in your code. Also, this is only going to work on the client, because only the client is actually rendering, the graphics of your game. Since we're going to be running this, actually, you know what? That's a good point. Since we're running this on the server, or at least a simulated server, this should actually be heartbeat. And heartbeat is an event that's basically the same thing, but instead of firing every render frame, it just fires basically every other frame in your game, so like after a physics update or something. And I'm sure this can be used on the client as well, so heartbeat should be able to be used on both client and server. Doesn't really matter. The point is that it's a faster way of using wait, but not only is it faster, it's a more appropriate way of using wait. So this is going to be basically the delay of our animation. So we'll use that later. First thing we're going to do is we're going to make a we're going to create a function that will return what value our transparency should be, or whatever value that we're tweening should be. And it's going to be a linear tween, which means that we're going progressively from point A to point B in, well, a straight line. There's not going to be any kind of, like, you know, weird delay at first. It's not going to be like sine or cosine or something like that. So I'm going to call this function, we'll just call it linear tween. And the parameters I'll give, let's see, we'll call it our start value, because we need to give it a start value. Basically, that's our start value is going to be the current transparency of the part. And then we're going to give what we want our new transparency to be, so our goal. And then the other two variables we'll need are going to be the elapsed time, so how much time has passed since the animation started, and what we want the length of our animation to be in seconds. So I'm going to call this, I'll just call this time. Okay, and this is just going to return a number. This function here is just going to return a number. We're going to take all these variables and we're going to do a quick calculation with them to return what the value of our transparency should be. So since we're tweening from our start value to our goal, we know that we're at least starting here. Okay, so we're going to say start plus, and then what we want to do next is, well, since our animation is based on time, we want a percentage of how much time has passed of our total time. And so the way that we're going to do that is we're going to take the elapsed time and divide it by the total time. And that's going to give us a percentage. So a percentage of how complete our animation is. So we're going to say elapsed divided by time. And then we have to multiply that by our goal, because this is just a percentage by itself. It's not useful to us yet. So we want a percentage of our goal. So again, times our goal. And actually, since we've kind of added start here at the beginning, we're gonna have to subtract that later on in here, if that makes any sense. Basically, since this is just a percentage of our goal, but we started here, we have to make sure that we're not just randomly adding something to our goal. So it's actually going to be times goal minus start. And this is going to return a number, which just, you can actually do whatever you want with that number. It doesn't have to just be for transparency. But that's what we're going to use it for. So, alright, so now I'm going to define some variables here that are relevant to our animation. So we'll say the duration of the animation will be 5 seconds. We'll say start transparency. We'll start the transparency at 0. And we'll end the transparency at 1. So we're going to make the object basically completely visible to completely invisible. And that's it for our animation variables. Now we're going to start the actual loop that's responsible for animating the transparency of the part. So, I'm not going to use a for loop, because a for loop implies that we have some kind of constant step or constant increment, and we're not using a constant increment. It's going to be based on time. So I'm going to use a while loop. And like I said before, the delay of our animation is going to be based on some run service event, whatever is most relevant. In this case, it's going to be heartbeat, because we're using a simulated server. So run service.heartbeat wait. And so the first thing we have to do is actually, since we need to keep track of when our animation starts, that's going to be our elapsed time part, we also need to save basically some timestamp right before animation happens. So I'm going to call this start time equals tick. If you don't know what tick is, tick basically just returns Unix time in seconds, which is kind of like your computer's local clock, which is, it's basically just a way of keeping time on your computer. So this is going to save, this is just going to be some number of seconds. And now we want to figure out what our elapsed time is, so how much time has passed during, or I'm sorry, since this start time here was declared. So call this elapsed, and that's just going to be the current time in the loop minus whatever the start time was. So for example, if this animation was 5 seconds long and it has been going for 3 seconds, then our elapsed time would be 3 seconds. So the next thing we have to do is basically just change the transparency of the part. I think we have all of our other details here taken care of. So part.transparency is equal to linear tween. Our start value, so our start value is going to be what we declared up here, so I'm going to pass start value. Our goal, or end value, that's going to be this. The elapsed time, that's kept track of here, so I'm going to copy and paste this here. And then our time, this is our total time. This is how long we want the tween to last for. And we want that to last for 5 seconds. So essentially, the transparency of the part is going to smoothly tween between 0 and 1 over a time period of 5 seconds. That's what we want in animating. So that should be done here. There is one problem with this, and that's that since this time isn't going to be exact, it's not going to, our elapsed time isn't going to exactly equal our total time by the end of this. And an easy way to fix that is what we're going to do is we're just going to clamp whatever our elapsed time is and make sure that it doesn't go over our total time. So we're going to use the min function for that. Let's say math.min. So we want to make sure that the smallest value, the minimum value, is always this time right here. And when it's not, if it goes over that time, we want to make sure that the new minimum is always our duration. So we don't want it to go over our duration. So this basically says we want this while the elapsed time is less than duration, and if this goes over duration, then just keep it at the value of duration, don't change it. And that's good because that's going to let us know later on when our animation is finished. So I'm going to come down here and say when our elapsed time is equal to our duration, then our animation has completely finished. So we're going to break out of the while loop. And that should be it, really. That should be it. So I'm going to clear the output window. I don't know why the part is already invisible, but that's weird. Okay. So when I run this script, we should see that this part's transparency smoothly transitions from visible to invisible over 5 seconds. And actually, you know what? Before I enable this, let's go ahead and print out. Let's print out what our elapsed time is. Actually, no. Let's print out what our linear tween is. So we're gonna print out what the transparency of the part is every cycle of the while loop. So we'll call this transparency, and we're gonna, well, we have to set the part's transparency to that, but we're also gonna print that out. So we'll say the transparency is that. All right, now let's run this. So you can see that going in the output window. All right, cool. All right, so the point is that the increments for the transparency are not constants.